On the very first one, on 13 and 14, we got to finish these from last week. So you have to make an equation. What's the formula to write an equation?
Y equals mx plus b.
Beautiful. All right, so we don't have y, we have d, and we don't have x, we have t. So we're going to write d of t. Do y'all remember doing these like 2 weeks ago where we had this graph?
No.
Negative. Oh, Lord have mercy.
Did we ever remember?
Oh, yeah.
I hope so. I mean, at least I remember doing them. Oh, Jesus. Take the wheel.
It's like a different equation for each
Yep,
one.
it's a different equation for each one. So we have 3 different pieces. We got this one right here. So what's
Oh,
the
yes, I remember this.
slope?
Oh, yeah, I remember.
Up one, right one.
Up 1, right 1. So what's that mean?
1.
1. And what's your y-intercept? 1. And then you, since it's like a piece-wise, you have to tell me what piece. So what's the x values that go with the first dot? 0. What's the x value that goes with the second one? 2. So it's between 0 and 2. Y'all okay so far?
No.
No?
I need
What?
the 0 and 2.
The x value. This x value is 0.
Oh, okay.
This x value is 2. That's the 2 pieces that it's between. Alright, so right here, this is our second one. It's a flat line. What is that called? When it looks horizontal.
It's just plain old.
It's just plain old 3, right? It's just y equals 3. Because there's no slope that goes with it. Or technically it does have a slope, but it's 0. Alright, what are the x values that that's between?
2.
And 7. Very good. Alright, so this piece, the last piece, is the part that we're going to do today. So let's remember how to do this. We do not know the y-intercept, right?
Correct.
So we do know the slope, though. What's the slope?
-1.
Didn't hit right there.
Just kidding.
1, 2, 1, 2, 3. So what is that? -2 over 3 or 2 over -3, either one. Alright, since we don't know the y-intercept, we have to use those parentheses, okay? So if it's inside the parentheses, that tells me that it moves left and right. So how much to the left did it move? Or excuse me, to the right, sorry. What's the x value? 7. There you go. Alright, and if it's inside, you have to take the opposite sign. So if we moved right 7, that's normally positive. What's the opposite sign? Negative. There you go.
Oh, so it's -7.
Because it's inside, which means you take the opposite sign. Alright, and then the number outside tells you how much you moved up. How much did you move up? 3. So that's a regular 3. Alright, what are the x values that that's between? 7 and 10. Does it have an arrow right here? No, so it stops right there. So it's between 7 and 10.
Is it the reason they're equal to? So it's
Because they're solid lines, they're not dotted. Yeah. Alright, the last one down here. Alright, so you got Kimmy thinks that the graph below and the table are representations of the same linear relation, okay? So Carla disagrees with her. Which one's correct?
Kimmy.
How? How'd you know that?
Because it's a rate of change.
What's the rate of change here?
-2.
Positive 2. Positive, we went up 2. So slope equals 2 here. And how do we find the rate of change between this one? Remember this guy?
Change in y.
What's the change in y between that? What kind of 2?
Positive.
-2. And what's your rate of change between your x's? What kind of, oh no. Negativo. Yep. So that's 2. All okay? So let's have the same slope. So who's right?
Carrie. Or Kimmy.
Kimmy's right, yep.
I was looking at Sawyer.
Because why? They have what? There you go, because rate of change on your paper is the same. But not only rate of change has to be the same, what else has to be the same for them to be the same line? What point? What specific point? Besides slope, what's so important besides slope? Y-intercept. What's the y-intercept here? -1. Ooh, and anytime I had the word intercept, I automatically thought of what number? 0. So what's my y-intercept here? -1. So Kimmy is correct because they have the same rate of change and the same y-intercept. Y'all okay? Yeah? No? Alright, so here's what we gotta do first. We have to, if you took your quiz late, I did grade those. If you took them this morning, they're not graded. I've been teaching all day. So if you took it this morning, I hadn't graded them yet, but you took them last week, they are graded in the computer. And if you will remind me at the end of the class, I will show those to you. But we need to do a checkpoint first from Friday. So checkpoints are open notes, but not open neighbor. This should be like real quick, fast, in a hurry. It's very, very easy.
Oh, crap.
Use your notes, cannot use your neighbor. You can use your notes, cannot use your neighbor. It'll be very, very quick and easy. Alright, yes. Okay, so you'll watch the video. Are you checking out right now? Okay. Alright, so look at those definitions up there. We're going to get rid of that first one because I don't really worry about that one right now. The one I want you to worry about is the second one. And it's a parent function. Is the simplest form, okay? Right? Remember those 5 parent graphs that we looked at before? Alright, here we go. Parent function. So, constant. What's it look like? Straight line, right? What about an identity? We didn't call it an identity before. What did we call it before? What? No. What did we call this before? 2 weeks ago on Math Workshop.
Crap.
What? Yeah, linear. Very good. Linear. Very good. All right, so what's the difference between a constant and an identity or a linear function? What's the difference between these two?
One is the one.
Which one's got the slope?
The identity.
The identity, the linear one, right? So this one has a slope. It's like it's at a diagonal. All right, what about this one? Absolute value. How do you know it's an absolute value? What's it look like?
A B.
There you go. Makes a V. All right, just for giggles, let's go over the other ones, okay? So you had x squared. What did x squared look like?
It was in like a square root thing.
This one's square root. What did this one look like? A U. Very good. A U. A parabola. Yep.
Thank you.
All right. What about a square root function? What did it look like? Well, you need an upside down parabola with a J. That one. 'Cause that's what a football looks like when it says thrown. When a football is thrown, it looks like an upside down parabola. The little guy standing right here throwing it, and he's throwing it to somebody else.
Oh,
And
Oh, I
that's upside
see
down
it.
parabola. Yep.
what's your way?
Yeah, that's a Toledo football.
So what's it look like? It's a little ramp. There you go. All right. So the square root is a parabola turned sideways, but it's only the top half. Why couldn't you have the bottom half of the parabola turned sideways? Because you can't square root a negative yet. We're getting there. All right. Last one. 1 over x.
That looks like random things.
It's like real funky, right? It was this one. It had the little top piece and had the bottom piece. How'd you know it was a rational function? How'd you know it was a rational function? Where's the x?
I'm in the bottom.
It's in the bottom, right? Y'all okay? All right. Here we go. Look at number 1. Identify. All you gotta do is tell me which one it is. What function is this? Absolute value. All right, what about number 2? That's constant, because it's a straight line. Identity, or you can put linear, right? T slash. I prefer you put both, because most of the time on the ACT it's going to call it identity, but a lot of times we call it linear in class. So I prefer you put both. You can just put ID and then slash linear if you want to. All right, let's go to the next page. All right, this is where you need your graphic calculator, okay? Right here. I am, but, well, not in the calculator yet, no.
The time is not.
Well, I mean, I can, but it's a lot easier to do it the way we've been doing. But I could show you now if you want, but I'm not going to do it right now. All right, let's look at this. So we lost 2 days last week, okay? So we're going to look at these a little bit differently than we normally do. So these first 2, this is what we've been doing for 2 weeks on those problems. Look at where this H is. Where's he at? Inside or outside? Inside. So if it's inside, we take the opposite sign. And where's it move? Which way? Right or left? There you go. All right, let's look at the next 2. These 2 guys right there. Where's the K at? He's on the outside. And we're going to do the same sign. I'm not going to change any signs. And where's that move us? Which way? Up and down. There you go. Mm-hmm. All right, then you can mark out this one, because we're going to do that in pre-cal, but we are not going to do that right now. We're going to do it in pre-cal, but we're not going to do it right now. So you can mark out the one that's got the negative in the inside. All right, so here's what we're going to do. We're going to do reflections when the negative is outside. So where's that move us? It reflects it over the x-axis, right? So it flips it upside down. Are y'all okay? All right, and let's look at the last ones down here. Dilations. What does dilation mean? What's it doing? What's it doing right here? Is being you got a number being multiplied, right? And we're only going to look at these 2 right now. Okay. Y'all good to go? Yes? No? Yes, ma'am. It's crossed out. We're going to do that in pre-cal, not right now. All right, so you got your graphing calculators? So here's what I've got for you. You don't have to have one of these, but I have these little guys printed out for you if you want to highlight the buttons that we push, so that way you can kind of have something to look back at. So does anybody want one of these? All right, come grab one if you want one real quick. I got several of them. You don't have to, and y'all should be good by the time class is over, but here you go if you want one. There's a couple of them on there, in case you need a couple extras. Anybody else? Last call? Last call, anybody else? Alright. Here we go. What's so funny? Alright, all the way down there at the bottom. Look all the way down there at the bottom.
Oh, they're doing. Oh, he's looking at it, his reflection. Like he's using the.
Sorry.
Oh.
Yeah, he's being pretty tough. Don't be weird. Alright. I didn't say you were weird. I said don't be weird.
No, yeah, I got bored.
Oh, I'm sorry. Well, we're not about to be bored. Here we go.
I'm good.
I saw a post on Instagram where you could like write something with the graphing thing.
Yeah.
Send it out the window.
What's the very first thing it tells us to do? Name the parent graph. So what's the parent graph here? Absolute value. There you go. And what was the equation of the parent graph, because that's going to be important, because that's what we need to plug into our calculator to see what's happening. So what was the equation? Y equals what?
Absolute value of x.
Absolute value of x. Alright, nothing added, nothing subtracted, nothing being multiplied. It's just y equals absolute value of x. Are y'all okay? Alright, so here's what we have to do. We have to plug this guy in our calculator first, because what we have to decide is we have to describe the transformation. So we have to describe what happens when we add this plus 4 in. Does that make sense to everybody? Alright, but absolute values are kind of funky to plug in, so let me make my screen a little bit bigger so that y'all can see what's going on. Alright, everybody ready? Okay, when we want to graph something, where do we have to go first? Y equals. And if you got stuff in there, clear it out, okay? If you've got stuff in there, clear it out. Don't cheat. Clear it out. Alright, so here's what we're going to do. If you've got that paper that I handed you, you might want to highlight this math button or circle it or scribble it in or something. You hit that math button first. Then we need to go over to number. Yeah.
Whoa, what? Back way up.
Okay, why?
Okay, sorry, you don't need an attitude.
Go to math. And your screen should be the same as mine.
Okay, we're good.
Got it?
Is that a fraction?
Yes, but you have to type it in a certain way. Alright, we don't worry about that. We want to go over to number. So you're going to hit the right arrow button. So if you've got that paper that I've handed you, you might want to hit the circle the right arrow button, maybe in a different color or something, so you see we did that second. And then what's the very first one that's there when you hit the right arrow button? Abs, which means absolute value. Now, if yours is updated, like mine is updated, it's going to pop up with the absolute value bars. If yours is not updated, can I have that? Can I borrow that? So Kayla's doesn't have the updated, which is not, it's not a big deal at all, okay? But hers just says ABS instead of putting the absolute value bars. Does that make sense to everybody? Alright, so here we go. What are we going to plug in first?
X.
The parent graph, right? So remember, X was right next to the green button. Alright, now if you have one like Kayla's, you need to close the parentheses. If you have one like mine, you just hit the right arrow button. Are y'all okay so far? Okay, now don't hit graph, we're not done yet. If you hit graph, go back to y equals. Alright, now what we need to do is we need to graph this one along with it so that we can see what happened. But already you should know what happened because this is an easy one. That 4 is outside. If that 4 is outside, we keep the same sign and it moves where?
Down.
It's the positive 4. It's going to move up 4, right? So here we go. Let's do it again. Hit the down button. And how do we graph absolute values? We hit math.
Number.
Abs. And this time we're going to hit X. Now look where that 4 is. That 4 is outside. So you either have to close your parentheses or you have to hit the right arrow button, then hit plus 4. If you type it in wrong, it's going to graph it wrong. And then we can hit graph. Alright, the very first one is going to be your parent graph. The very first one is going to be your parent graph. Where's your parent graph starting at? Yes. Where's the parent graph starting at? 0, 0, which is called the origin. Every time your parent graph, you go to the origin. And we already know that the plus 4 told us that graph was going to do what? Go up 4. Y'all okay? Alright, so here we go. So this is going to move up 4 because it told us to describe it. I'm positive. Look, you got it right there. Y'all okay? Pretty easy stuff? Alright, let's go to the next one. Huh? Describe the transformation. What happened between the parent graph and the blue one and the red one? The blue one's the parent graph. Do we? 4. Went up 4. Alright, so we're going to skip number 2 for just a minute. Let's focus on the same ones. Let's look at number 3. The direction said name the parent graph. What was the parent graph? Absolute value, which is what? Y equals of X. There you go. Alright, then it said describe the transformation. We should not be on our calculators yet. We're not there yet. This 3 is inside. If it's inside, what do? Opposite sign. So normally a +3 would tell you to move which direction? To the right. But since it's the opposite sign, we're going to move which way? Left 3. Okay? Now let's take our calculator. Don't clear the first one because you're going to do more work you don't need to do. Clear the second one, okay? Right? Y'all with me? Everybody off their phones and with me on their calculators? If you cleared the first one, just do it again. All right, how do we put an absolute value in? Math over to number. All right, now look at where the +3 is this time. The +3 is on the inside. So you hit x + 3 and either hit the right arrow button after the 3 or close your parentheses after the 3. Hit graph. And what should have happened? It should X, just like it says, X and then +3. Then hit your right arrow button, then hit graph. Good. First one's your parent graph. Second one's your transformation, and then move left 3. Right? Yes, ma'am. What happened? Only one function after 3 plots for graph. Okay, give me a minute and let's finish this. I'm gonna do something independent. I'll fix it, okay? I have to play with it because I can't remember how to do it. Are y'all okay? Yes? No? I'll do it. All right, here we go. Let's go to number 5. Okay, skip to number 5. Go to y equals. Don't clear out the first one. Everybody with me on the calculators? Not doing anything crazy, but we're on number 5. All right, now here we go. Look at this guy right here. What does that negative in the very, 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 very front tell me? Reflects where? Over the x. You have to tell me over the x. If you just tell me reflects, you're not going to get all your points, okay? All right, what does this -2 in the back on the outside tell me? He's going to move down 2. Very good. All right, it told me to name the parent graph. What's the parent graph? Absolute value. And what's the equation? Perfect. All right, here we go. Got your calculators? All right, now here's what's different. When you have that guy in the front, so if you've got a calculator, you may want to make a note on this, on the paper that I handed you. You may want to make a note of this. The only time you hit this negative down here, is when it's in the very front. So if you have a paper calculator, you may want to say see number 5 on page 29 or something like that, okay? All good to go? All right, so you're going to hit the negative. Go all the way, we're in y equals, all the way down at the bottom. Right? Good to go? Ethan, you already did it?
I think so.
All right, so let's hit math. Go over to number. Hit enter. What's the only thing on the inside? X. All right, if you've got the updated one, you just hit the right arrow button. If yours is not updated, you must close your parentheses. If yours is not updated, you must close it after the X. And then you hit subtract. Do not hit the minus, hit the subtract. Okay, if you hit the wrong negative, it's going to tell you error. Okay? All right, now hit graph. And Ethan, do you get the same thing?
No,
No.
What happened was,
What'd you do?
in number 6,
Oh. Okay. Well, yeah, that would be a big deal then. All right, so did it flip over the x-axis? And did it move down 2? There you go. All right, y'all okay? The only reason we're using our calculator is because y'all are visual people. Most of you are visual learners. That's the only reason we're using our calculator, okay? All right, let's do number 6, and then we'll go back to 2 and 4, okay? All right, Ethan, we got a fraction, okay? Oh, crap, I hit the wrong button. All right, so Ethan, it is still so much easier just to type it in the way we normally do, okay? I will show you. You may show you? Okay. All right, so you hit, we do it later. Let's do this first, and I'll show you, okay? All right, how do we type in a fraction? Parentheses 1 divided by 5, yeah.
Do you have to?
Yes, because if not, it's going to say just the 5 times the whole thing, and not the 1/5 times the whole thing. All right, and we got an absolute value. How do we do that? Math over the number, enter. All right, now look, this is not a negative. This is x subtract 1. Make sure you hit the subtract sign, okay? Don't hit the negative, hit the subtract. And then you either have to hit the right arrow button or you have to close your parentheses before you hit +3. Are y'all okay? All right, hit graph. It is correct. It's funky. It almost looks like a straight line, right? All right, so let's look at what happened. Y'all ready, gentlemen? Waiting on y'all.
We're ready.
Sure?
Yes, ma'am.
Okay. All right, what does this guy do?
Moves left. Right.
It's opposite sign. You got to move right 1. And what's this guy do? It moves it up 3.
Is the absolute?
It's an absolute value. Yep, I forgot to leave with that, didn't I, Jack? Y'all okay so far? Okay. But what made the graph go from, like, look, he stretched it like this normally, right? He's a normal V, but then he went all the way out here and he stretched which way? Okay, so look, my arms are like this, right? And he's going from here and he's stretching all the way out almost straight. So which way did that go? Vertically or horizontally?
Horizontal.
Horizontally. So he stretched which way? What's the word? Horizontal. Okay. What is the only thing left that made it stretch horizontal? Dilation of what number? It's the only number left.
7.
You see it's 7.
I don't know. I just threw it.
What's the only number left? The
Sorry.
oh. Wait, next one. Stop. Up here.
On our graphing calculator. I'm sorry.
Don't sit there and act like you weren't taking care of that question, sir. Don't even.
That was early.
That was early. What's the only number left up here?
What? 1/5.
1/5. And Matthew, what did that 1/5 do? What word? Dilation. And the dilation means that it moved it stretched it which way? Horizontally. So let's try that again, okay? 1/5 means that it dilated by 1/5. Which did what? Stretched which way? Horizontally. There you go. Y'all okay? Or you could say compressed vertically. Either one is the same thing. Alright, we're not going to do number 7.
Stretches
Horizontally. Because it pulled it this way.
That was like the easiest
Oh,
one.
so if it pulls it, it stretches.
Yep. Alright, so let's go back to number 2. Here we go. Back to number 2. What's the parent graph for this one? Which one? Linear, or we could call it identity. There you go. Alright, let's go. Here we go. And what's the equation? Y equals just y equals x, right? Alright, so before we do anything, we should already know, what does this guy do to the graph? Moves it down 5. There you go. Alright, and then grab your calculator. Manners, son. Clear everything out in your calculator. Go away, you can clear everything out. Ethan, up here. Here we go. We're up here. Who cares? Up here. What's the parent function? Y equals x. What's the transformation we want to see what happened?
That's down 5.
X subtract 5. Alright, hit graph. Let's check our work. Because what should the graph do? It should move down 5, right? Let's see if it works.
It worked.
Woohoo! It originally was at 0, and then it went down 5 for a y-intercept. Y'all okay? Alright, let's move to the next one, number 4. What's wrong? Nothing? Cool. Oh, there's all kinds of stuff y'all hadn't learned. This thing will do.
Gail, are you wearing my shirt?
Alright, number 4. Number 4. Number 4. What is that 4 being done to the x? Is it being added, subtracted, multiplying, or divided? It's being multiplied. And if it's being multiplied, what's the word that we use? Dilated. 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 Dilated by 4.
But you're kind of blonde, okay?
What? What? I'm not kind of blind.
On the bottom.
Alright. Well, that's dye. That's $80 worth of dye. Alright, so what kind of graph is this?
You're white.
Identity.
Good job.
Or what is the other one we could call it?
Linear.
Linear. Make sure you know both of them, okay? And the parent function is y equals x. Let's go to our calculators. Alright. So we got y equals x in the first one. And then we've got y equals 4x in the second one. Y'all okay so far?
Yes.
Alright, hit graph. That's the parent graph. That's the first one.
Why is yours so small?
Because I have my settings set like that.
Oh, they did that.
Alright, so what happened? It went from being like this, and it moved which way?
Up.
Up. So I got stretched which way?
Left.
Vertically.
Oh.
Y'all okay? Yes? No?
Yes, ma'am.
Maybe? Okay. Alright. Let's see what we can do with number 1 down here.
Number 1.
Alright, now the only thing that number 1 says to do is what?
Graph.
Graph, okay? Don't just be doing things just to do things. Follow the directions. Alright, so here we go. Plus 3 is not on our calculator. We're not there yet. Put it up. Put it up.
Put it up, Sawyer.
Plus 3 is on the inside, right? I'm going to do it without it first. On the inside. And if it's on the inside, we take what kind of sign? Opposite sign. So plus 3 normally tells me to move right 3. But if we take the opposite sign, which way are we going to move? Left 3. So that's where our vertex is going to be. Right there. Alright, so here we go. So we have, that's our parent graph, right? Our x value to start with, what's this x value? X value. What is that? Isaac, I can't see with your hands up everywhere playing with your hair, dear. What's the x value here? That's the, -3. So let's plug in the next one. What's this value? That's 3? What is that?
1.
That's a 1 right there?
Oh, I think you asked like how did we get from there?
What is that value right there?
-2.
-2. Plug that in. What's the absolute value of -2? How much is it? +2. Waiting on y'all. Because we have 5 minutes left. And the more y'all talk, the less we can do in class. Which means y'all got to do it for homework.
Wow.
Ready? Alright. From here, all you're going to do is you're going to go out 1 and up 1. And then out 1 and up 1 on each side, okay? Don't think of it as slope. We're not going to think of it as slope. So what's the reason we're doing this? If I plug in 1, what's the absolute value of 1? 1. +1. So that's why I went out 1, up 1. If I plug in -1, what's the absolute value of -1? That's why I went left 1 and up 1. If I plugged in 2, what's the absolute value of 2? 2. That's why I went out 2 and up 2. If I plug in -2, what's the absolute value of -2? 2. That's why I went left 2 and up 2. Are y'all okay? It's real easy. That's all you got to do. It doesn't say to strive. It doesn't say do anything but graph it on your paper. All right, let's flip over. No. All it's have to do is graph the transformation. All right, number 2. What are we dealing with here?
Absolute value.
Absolute value. What's this minus 4 right here? Tell me I'm going to do.
Go down.
Down how much?
4.
4. There you go. That's where your vertex starts. 1, 2, 3, 4. Down 4. All right, it's an absolute value. Anytime we have an absolute value, we're just going to go over 1, up 1 on each side. And you can make it as big or as small as you want to. Try to make it a decent size so you can see what's going on. Yeah. I mean, at least, you need at least 3 or 4.
What they say, bigger the graph, the more likely you are to get it correct. I was just
You're just making stuff up now. All right, number 3. Here we go. Number 3. What's the only thing that this guy tells me to do? Reflect over the x-axis. There you go.
When did you say we were going to do y-axis? You said.
That's in pre-calc. All right. So, where's my vertex going to start at? If I'm not adding or subtracting anything back here, 0, 0, right? But look, instead of going out 1 and up 1 on both sides, what am I going to do? Instead of going out and up,
Go down. Out, down.
out and down. There you go, because it's going to be flipped over.
whoa.
Very good job, Ethan.
I tried.
See how it's flipped upside down? Real okay? All right. Last one, number 4.
We're never gonna get there.
What's this one tell me to do? It's inside.
Right.
Very good. So that's going to be right 2. Hold on a minute. We're not done yet. This guy tells me right 2. That moves up 3. That's where you put your dots. You go right 2, up 3, then you put your dot. You're all okay?
Yes, ma'am.
All right. And so am I going to go out 1, up 1, or out 1, down 1 on both sides?
I want up one.
1, up 1, because it's positive, right?
Yeah.
And here's what I want you to do when you get finished. I want you to take your handy-dandy calculator,
Yeah, but it is.
You gonna do all these?
and I want you to check all 3 of them for 2 reasons. 1, I want you to make sure that you know how to check them for your test. And 2, I want to make sure you know how to plug them in correctly for your test. All right, so try all 3 of them, and then we are finished. You have 3 minutes left. You have 3 minutes to check all of them.